Welcome to Security Weekly's Virtual Hacker Summer Camp 2020. I am your host, Matt Alderman. Joining me for this interview segment is Michael Borohovski, known as Borski from Synopsys. Now, it's a new role at Synopsys because you were the former co-founder and chief technology officer at Tinfoil, which was just recently acquired by Synopsys.
Right.
So welcome, Borski.
Thank you for having me. Technically always co-founder, but former CTO, I guess.
Yes. You're right. You're always the co-founder, but former CTO. Now you're in a software director of software engineering role, I think, with Synopsys.
Yeah, so I'm a director of software engineering in the architecture group now at Synopsys.
Yeah, what's interesting about Tinfoil, Paul and I did a lot of research with the Tinfoil folks back when we were at Tenable. And so we know the product pretty well because we did a bunch of research back then when we were looking at application security. And I thought it was a very interesting acquisition by Synopsys to pull in API security as part of this broader application security portfolio. I think APIs are sometimes forgotten from a security perspective in these kind of new applications.
Yeah, no, I mean, that's exactly right. And we're seeing more and more attacks via APIs as people start recognizing the fact that pretty much everything under the sun now is built using some semblance of backend APIs or some combination of backend APIs. And there wasn't really anything, especially at the time and even now, to look for vulnerabilities in them. I mean, there's been for a while these sort of WAFs that have been applied towards APIs, but very, very little in the way of actual vulnerability detection or actual vulnerability assessment for APIs outside of, manual pen testing and things like that.
Yeah, I mean, we see the proliferation of APIs all over the place, right? We're using microservices, so we're containerizing stuff, building out microservice architectures. The communication between a lot of these microservices are API communications.
Yep.
We're also seeing a lot on the mobile side as well, right? So you've got a mobile application, it's communicating with an API to the backend service. And, when you think about a traditional security test, right, you're thinking static analysis, you're looking at code, you're doing maybe a dynamic scan, but who's really checking the APIs? And how do you identify vulnerabilities in those APIs? So give us a little bit of an overview of what do you look for and how do you scan for these APIs and these vulnerabilities?
It's a really good question, right? So at the end of the day, what are you looking for, right? You're looking for anything that is internet connected that may or may not have a website, right? So imagine embedded devices or even, mobile apps. If they're talking to, if they're completely self-contained, if they're some toy game that perhaps does like a Bluetooth connection with friends to be able to use it on your phone, that's one thing. But something that actually talks back to some server somewhere on the internet is almost certainly going to be doing it over some form or some form of a RESTful API or similar. And so the big question becomes, how do you, we've spent many years building dynamic analysis tools, for example, to run against actual web applications with actual web interfaces that you can click on things and find inputs and vectors and so forth. It's much harder for APIs. And so the thing that you end up having to do is, first of all, you need to take an assessment and get discovery done, right? You need to figure out, or you can do it yourself, but you need to figure out where all of your APIs are, right? Typically, this starts with looking at the applications that you provide and seeing what APIs that you've built underneath that. And then also looking at anything that you integrate with as well. And then the next question becomes documentation, right? So if you don't know what your API is supposed to be doing, there's no way you can effectively secure it. And so we spend a lot of time trying to help customers figure out, that the fact that they need to document their APIs using some sort of common specification. We generally recommend Swagger or OpenAPI. And then once you're there, then you know where the APIs are, what they're supposed to do, how you're supposed to authenticate with them, and so forth. And then you can start making assessments as to whether it's doing what you've designed it to do, right? At a very high level, what is a security vulnerability, right? A security vulnerability is a bug, effectively, in which the application does not perform in the same way that the developer originally intended it to. Well, you can't know how an API is supposed to perform unless you document it so you know what it's supposed to do. And then once you've done that, you can decide and decipher whether the API is performing the way that you intended it to or doing something else entirely, or if you missed an edge case. That's kind of where we generally start.
Yeah, and I think discovery is probably one of the big challenges right out of the gate, right? How do I know where all these API endpoints are, right? I mean, the developers know, but as a security professional for a second, thinking that's outside of the application development team, how do they even know where all these different API endpoints are? So I think discovery is one big challenge. Do you have a good solution of how do you discover for these APIs as a starting point, just to know what's out there?
It's a really good question, and yeah, I would agree that discovery is a really hard challenge. I would challenge you on the assertion that developers know what all of their APIs are, because most developers don't. Right? They use it once. They perhaps they build some underlying API, but they rarely at this stage, although it's growing, they rarely document what those APIs are and where they are and what they're supposed to do and how they're supposed to act. And so as a result, developers generally have a best guess understanding of what their APIs are supposed to do, but very often, we'll run a scan on one and we'll discover, oh wait, it also has these three endpoints when that was not explicitly designed intentionally by the original developer and was simply added later. But to answer your original question, yeah, there's a number of ways to do it, right? One is you can look at the application manifest and actually look at the source code statically to try and decipher where the APIs are. You can listen with a network proxy to try and see what traffic is being sent where. You can listen with an interactive application security testing solution like Seeker from Synopsys will listen on the background as traffic is handled and inform you of where it's going and what's happening, so you can decipher and discover where what APIs you have and how they're being accessed and talked to, and then hopefully start documenting.
Yeah. Now, documentation's the second piece, right? I'm familiar with Swagger and the use of Swagger. If it's not documented, does that limit how much testing you can do against those APIs? Do you use that documentation as part of your test sequences, or can you actually do a number of tests not even knowing what that API is going to do?
Great question. So there are some tests that you can do ahead of time without having anything documented, right? You can look for load testing things and make sure that you can't arbitrarily retrieve data from these endpoints without proper authentication and so forth. But it's effectively minuscule when you think about the greater surface area of APIs, right? Just like with a web application, how much is there to really glean from a bank from their externals? The answer is very little. You'll end up with a bunch of marketing pages. You'll end up with information about various types of accounts and whatever, but you're not going to end up with anybody's actual information. Why? Very simple, right? You haven't authenticated with the application. Now, authentication on the web is a relatively well-known or relatively well-defined subject, right? Typically, you'll have a username and a password form. For APIs, you can basically do anything you want, and it's pretty undefined. And without authenticating with an API, it's going to be very unlikely that you'll be able to glean any useful information. And so the documentation is useful for a couple of things. One, it allows us to define how to sign requests, how to authenticate requests, how to literally talk to the API appropriately, which is a little bit easier on web applications because they all speak one common language, right? HTML, forms, and CSS. And so you can ignore the CSS for effective reasons and then think about just JavaScript and HTML and start parsing the page. You can't really do that for APIs. Short of things like HATOAS and so forth, there's no real way to crawl an API. It's hard to figure out, okay, now that I've authenticated, well, now what do I do? Where can I go? What are my options for what to attack? And the simple reason for that is that there is no concept, generally speaking, of linking across various endpoints for APIs. There's only this concept of you have a number of endpoints, specifically talking about RESTful APIs here. You have a number of endpoints and you need to document how, what parameters they might expect, what the types you think they're supposed to accept are, so that we can successfully attack it. Now, there is one exception, which is for some APIs like GraphQL APIs. In that case, documentation actually isn't required, which is pretty fantastic. Tinfoil originally launched GraphQL scanning back at GraphQL Summit last year, and then Synopsys now does GraphQL scanning through Tinfoil as well. But the whole idea there is it's effectively self-documenting, right? If you have a GraphQL API, we can ask the GraphQL API to provide us with its schema via something called introspection, and then we do a bunch of analysis on our side in order to basically prune that search space and allow us to scan a GraphQL API by just handing us the GraphQL endpoint.
Interesting. So a lot of the same challenges we had in the early days of DAST and unauthenticated versus authenticated scanning exist in API security as well. If you're not authenticated, then you don't know if there's a GET or a POST or different calls that are in there to know what to test against, right?
Yeah, that's exactly right. And it's actually worse with APIs, right? Because at least with web pages, you'll have a form of some sort, and you can, in most cases, figure out how to submit that form. Now, people do crazy things with implementing SAML incorrectly or using, OIDC incorrectly or whatever. But those are generally bugs in the implementation. There's a relatively well-defined set of ways to authenticate with most web applications. I would say, outside of that are exceptions. With APIs, there is no well-defined one way of authenticating. I apologize, by the way. I foster kittens, and they're just going absolutely nuts in the background. The joys of working from home through COVID, I suppose. But nevertheless, so you have these various methods of authentication. You can use various OAuth 2 types, grants for client credentials or password auth and so forth. You can use query parameters. You can use header parameters. You can sign requests in some other way. There's a bunch of different ways you can do these things, and on top of that, you can combine them, right? So you can use an API secret key and OAuth, right, if you wanted to. Right. And so you have to be able to work within this scheme of very configurable authentication schemes, which we try to handle through our API scanning by basically treating these various authentication pieces as effectively Lego building blocks that you can basically drag and drop on top of one another, and then it'll apply transformations using each authenticator to the various requests that we're sending in order to make sure that we're successfully authenticated.
Now, one of the big challenges I see with AppSec right now is this concept of DevSecOps, where you bring security into the DevOps CI/CD pipeline. How are you addressing the integration of API security testing into the development process for the developers to get a good idea of, do they have vulnerabilities in their APIs? Kind of walk me through where the different integration points in the CI/CD pipeline exist for this type of technology.
It's a good question. So generally, you're right, there's a few different connection points, right? So people will use static analysis generally as they're developing software, right? The reason being that you can integrate with an IDE and things like that, and that's really helpful. But where it comes into actual, dynamic testing as part of a CI/CD pipeline happens, during the CI/CD pipeline, right? So when you've run your build and you are about to deploy it, perhaps it's past, your linters and your license checks and so forth. You can kick off a scan with, the Synopsys or Tinfoil API scanner, and then within typically a few minutes, discover either you have or don't have any new vulnerabilities. Now, one of the big benefits of API scanning over web scanning is web scanning can take significant amounts of time, right? Due to the fact that it requires real browsers, you have to execute JavaScript successfully and replay events and things like that. It can be time consuming to be thorough and extensive. With APIs, it's less true, right? And the reason for that is because, the way that we've built it is to make it really, really easy to build distributed systems. But in addition to that, it's just a much more self-contained and well-defined space, right? You don't have to worry about JavaScript. You don't have to worry about browsers. You pretty much only have to worry, generally speaking, about HTTP or TCP or some single protocol, and it allows you a lot more flexibility to be able to make requests faster and without having to worry about or as much about how long the scan will take. I mean, typically we've seen scans go from anywhere from sub 30 seconds up to, I think, a maximum of about 12 minutes, which is perfectly fine for integration into a CI/CD pipeline. The other thing is that we focus a lot on integrations themselves, right? So we have integrations with Jira, we have integrations with Jenkins. Everything that we do is API driven as well. So, if there's anything you can do through the UI, you generally can do it through the API. Otherwise, we consider it a bug. And so we want people to be able to integrate with, any tool that they want to integrate with, whether it's your CI/CD pipeline, whether it's your issue tracker, whether it's your GRC tool for compliance, or whatever it is that you need to integrate with. We want you to be able to do that really trivially. And I think speed is important for that as well.
Yeah, I mean, you don't want to slow down the pipeline, right? You can't.
That's
I mean,
right.
the developers will get upset if you slow down the pipeline too much because they're trying to get code out the door. So as long as you keep it low touch, you can do some automation and keep the time windows down. Now I can effectively do some very good testing through the CI/CD pipeline
Exactly.
to make sure things are more secure. How is the tinfoil portfolio getting rolled into the rest of the Synopsys portfolio? Because I know there's been a lot of acquisitions from Synopsys over the years.
Yep.
I know they're integrating them together in a more centralized platform. How does tinfoil now fit into that overall kind of platform structure?
It's a good question, right? So being on the architecture team, I get a lot of purview into this, which is really nice. But to make a long story short, the way that we're kind of thinking about things is, so we have Polaris, which is our platform to try and bring all of these tools together into one sort of single pane of glass, if you will, and one control system. The interesting part about it, though, is the way that we think about it is Synopsys has basically made acquisitions to acquire the best in breed of various verticals in security, right? Now, every single one of these types of tools, DAST included, hey, I ran a DAST company for 9 years and I'm still doing it basically through Synopsys. And I can tell you there are problems with DAST. There are also problems with SAST and IAST and RASP and, pick your favorite acronym du jour. The thing that Synopsys is trying to focus on, and that I think is really intelligent, is to be able to take basically the strengths of various tools and have them make up for each other's various and respective weaknesses. DAST can do things to verify vulnerabilities that SAST finds that SAST normally can't verify due to the fact that they don't have access to a running application to test against. And vice versa, things that DAST normally can't find, an IAST tool can absolutely find, because DAST will never know what calls you're making to your cryptographic library to make sure that you're using a sufficiently secure algorithm or parameters. But IAST can know that, right? And DAST can exercise it. And if you can make these tools talk to each other in such a way that they can literally help each other cover up their own weaknesses, thus bolstering their own strengths, I think you have a suite of tools that frankly, that'll be hard for any other competitor to beat.
Yeah, I agree with you. I think the application security space is so vast in the number of submarkets that are there. I think what Synopsys is doing by bringing all these best of breeds together into a single interface has a lot of value to really get to that kind of nirvana state of DevSecOps, right? And because it is so many different tools, and if you're using 4 or 5 different platforms, you're losing the integration, the ability to leverage the strengths of all those tools. So I think what Synopsys is doing is actually fantastic.
Yeah, I agree. I mean, even with tinfoil, when we first started the company, we started with dynamic analysis because that was where we thought was the biggest, need. That was where the biggest dearth of, frankly, that was where the worst and crappiest tools were. And so we wanted to kind of fix that problem. But our whole goal from the very beginning was to build this sort of suite of best in breed tools. And it was just going to take us forever, right? We were doing it from dynamic analysis. We started with building the API scanner. Then we moved into GraphQL scanning and so on. And we were going to continue doing that, expanding our product portfolio until we eventually ended up building a bunch of tools that could help each other bridge the various weaknesses and bolster each other's strengths. And then when we started talking to Synopsys, it turns out that was kind of what their vision was too. So we were very excited to come in and help and basically continue building that same vision.
Yeah, it was a great acquisition. Borohovski, thank you for joining us on this interview segment.
Of course. Thanks for having me. I appreciate it.
Yeah, you're welcome. And if anybody wants to learn more about Synopsys, please visit securityweekly.com/Synopsys. And with that, we're going to take a break, and we'll come back soon with more interviews for Virtual Hacker Summer Camp.